All right. Okay, 4.1, 1921. So let's start with 4.1, 19/5. 19/5. 4.1, 19/5. This one says, suppose the graph y is equal to x to the 1/2 is shifted to the left 7 units.
Priority 1 message coming in on secured channel.
Okay, shifted to the left. Well, we know this is the square root. Okay, we know that's the square root. You can write this as y is equal to the square root of x. Okay, we know that 7 units to the left would be a positive. So you could either write this as y is equal to x plus 7 to the 1/2, or y is equal to the square root of x plus 7. Remember, the horizontal shift is always the opposite. That's a good test question. It's real short and sweet. Parentheses, plus 7, close parentheses. Let's see if they'll take to the 0.5. Yep. I just didn't want to type in 1/2. That's a good test question. Whoever sent that one, that's a good test question. 4.121/6. 4.121/6. Suppose you have the graph x to the 7/2. Y is equal to x to the 7/2. Is stretched by a factor of 6. Ugh. Stretched by a factor of 6. That means 6 is going to go out front. And then shifted up 3 units. So that means a vertical shift of up 3 units. Okay, well, let's go back to our handy dandy. We know this is going to go out front because of orientation. We know that this is x to the 7/2, so you can put that 6 in front of that, and then you can just add the 3 behind it. So it would be y is equal to 6x to the 7/2 plus 3. Or you could put it in a radical, and it would be 6, let's see, the square root of x to the 7th power plus 3. That square root would end right there, sorry. So however you want to write it, I would probably write it like that. So 6x, well, 6x to the 7 divided by 2, and then plus 3. Good test questions, both of them. Next, 4.2, 13/6. 4.2, 13/6. Okay, we've got f of x is equal to 6x squared. And g of x is equal to 1 over x. And they want to know fog and Goff. So they want f composed of g and g composed of f. So f composed of g and g composed of f. Well, when you do f composed of g, f is going to be written with big parentheses. So that's going to be 6 times big old set of parentheses squared. And then the g of x is going to be plugged in. So that's going to be 1 over x. And that's going to be equal to 6 times 1 over x squared, which is 6 over x squared. G composed of f, I'm going to write g with a big set of parentheses. So I'm going to rewrite g with a big old set of parentheses. And f is going to be plugged in. And f is 6x squared. So your final answer is 1 over 6x squared. Excuse me. So that would be 6 over x squared. And this one would be 1 over 6x squared. Another good test question. Y'all settle down, please. Next question. That's the same one. So hopefully, did that answer your question, Mr. Melnick? I didn't see who sent the first one. That answer it? Okay?
Yeah, I thought that was hers, but same thing. Yeah, it works. Thank you.
4.2 15/7. 4.2 15/7. F of x is equal to the square root of x minus 5. G of x is equal to 4x minus 5. They want f composed of g and g composed of f. Hold on just a second. Okay. So this means f, I'm going to rewrite f with a big set of parentheses, and I'm going to rewrite g with a big set of parentheses. So that's going to equal the square root of a big set of parentheses minus 5 and 4 big set of parentheses minus 5. And that means I'm going to plug something into this right here, and that's going to be g. And I'm going to plug something big right in here, and that's going to be F. So, what am I going to plug in here? G, 4x minus 5. What am I going to plug in here? Square root of x minus 5. And simplify this. It's going to be the square root of 4x minus 10. And this, you can't simplify this. You just make it look better. It's 4 square root of x minus 5 minus 5. Okay, it won't let me answer this question, but that's the answer. It should be the answers. Let's look at that second one. Hold on, did I not simplify it? Okay, you can factor out a 2, and that's fine. That answer is the same as that answer. I wouldn't factor out anything. I'd just leave it like that. Good test questions. All 3 or 4 of these so far are good test questions.
Hubert, I figured out the answers to the 2 questions I sent, so you don't have to go over those.
You sure?
Yes, sir. I finished them.
Well, let me see. Somebody else might have the same question, so I'm going to look at them.
Okay.
And I can tell you if they're test questions or not. So this is 4AT. I don't know what that means. 3 at 3. So this is your number 3. Let's see what kind of question it is. And I'll tell you if it's a, oops, sorry. I'll tell you if it's a test question. Well, I'm looking at it. The reciprocal function, f of x is equal to 1 over x, decreases on, well, I'm just going to draw it. That's where a parent graph comes in. This is why you got to know your parent graphs. F of x is equal to 1 over x. That's half a volcano. Okay, so we read from left to right. So what is your function doing?
Coming in on secured channel.
What is this function doing? Put a car right here. What is your car doing as it goes from left to right with this function? Well, that's decreasing, Hubert. Okay, what about here? What's it doing here? It's decreasing. So this function decreases from left to right. So it's decreasing from negative infinity to 0. And it is decreasing from 0 to infinity. Is it a test question? It could be, but it's not knocking down my doors as far as, I mean, you might have that on a test. You might have it on a standardized test, but I wouldn't go out of my way to put it on the test unless I just accidentally put it on the test. You got to know your parent graphs. Let's look at that last one. 415/8. Identify the type of function from its equation. Okay, it's a square root function. It's going to be stretched. I mean, it's going to be compressed. So let's look at it. We know that the parent graph for square root f of x is equal to the square root of x. Looks like this. Okay, our function, and I'm going to rewrite our function over here. I'm going to write it in pink. F of x is equal to 7 times the 10th root of x. Well, the 10th root, that just tells me that it's a square root function. It looks like this. It might be a little bit more squared off because remember when I told you that you have an even function, the higher it goes, the more squared off it is. Well, same thing here. So it might look something like this. The 7 says what? The 7 says it's going to be skinny. Now, how do you get skinny? Well, you push on the x-axis, you compress along the x-axis, and you stretch along the what? Y-axis. So I would say it's going to look something like maybe this. Of course, I may be wrong, but that's why you have the graphing calculator. So on this question, you would take your handy dandy calculator and you would say y is equal to clear and clear. And I'm going to do 7 times the 10th root. Well, you could put in the, I think it's under math or it's somewhere under here. I'm not going to put it to the 10th root. I'm going to raise it to the 1/10th power. So parentheses x to the 1/10th power, 1 divided by 10, and then put parentheses around that. So 7 times the 10th root of x, and graph. And zoom standard. Okay, I was a little bit off. Well, yeah, you just don't show it. You could zoom in and then show it a little bit further down. Because the square root of 0 is 0. Yeah, it would be 0, 0. You got to do a zoom. Let's do zoom first quadrant. Okay, well, you see my picture and their picture. I mean, there you go. And what else are they going to ask? It's a special power function with a power of 1/10. I like this question. This is a good test question. Now, every one of these were good test questions. So I applaud you for doing your homework. It's amazing how many test questions are in your homework. That's why everybody should do their homework. So for the, let's see, there's 16, there's 15 So about 11 of y'all, 11 or 12 of y'all are actually doing homework. Some of y'all, I don't understand what y'all are doing. Y'all just vegetating, I guess. I don't know, but most of y'all, about, like I say, 11, 12 of y'all are actually doing homework. So that's good. All right, let's pull in your handy dandy slideshow. How far did I get with the 4.2 the other day? Did anybody look in your notes? Anybody? Miss Hollister, maybe? 4.2, and let's go ahead and look at 4.3.
The last thing that I have in my notes is us going over like the F of G and the G of F.
Okay, composition.
Yeah.
Okay. There's F composed of G, G composed of F. I think we left off on a question like that. Okay. Excuse me. Yawning for some reason. All right. So anytime you have one question like this, let's go to slideshow. I'll just draw it and then we'll go. F of X is equal to square root of X minus 5, and G of X is equal to 2X squared minus 4. And they want you to graph F plus G. Well, there's not anything you can do here, okay? When you graph F plus G, or when you have F plus G and you've got two terms that are not very compatible, there's nothing you can do, okay? All you can do is write square root of X minus F plus 2X squared minus 4. That's all you can do. Because when you got a radical, you're limited to what you can do as far as combining like terms. So this one says add. Well, that's all you can do is just put a plus symbol between both of them. Now they want you to graph it. Well, it's gonna be a funny graph. So let's graph it. Let's take our handy dandy calculator and let's graph y is equal to clear, and that's going to be the square root. Hold on a second. It's in the freezer. Okay. All right, square root of X minus 5. X minus 5. And then go to the right. And then plus parentheses 2X squared minus 4. Again, the only thing you can do is just put a plus symbol there and graph. So go ahead and be zooming that out and see if you can find it. Okay, I'm sorry. Zoom. I'm gonna do Zoom standard. And Zoom fit. Okay, there we go. And I'm gonna zoom out. We'll go down because we see us down here. I'll hit zoom out. See, that's all you got. I mean, so the best thing to do is hit trace, and it starts. There's where it starts. It starts at 5.45 and 56. Man, you can go to the window table and go up, and you see that you can't have a negative under the radical. So there it is, starts at 5 and 46. So there's not much you can do with some, and that's what I'm trying to tell you. Sometimes when you're dealing with these compositions and adding and subtracting, there's not much you can do but just add it and get a messed up graph. And then, of course, after that, if they ask you what f of 6 is, or f of 10, or f of 15, then you just go to your calculator and you just type it in. I don't like table set. Let me go to table set. Yeah, I don't like that. You might want to change that to like 1. And that might be a little bit. There we go. And now you can go, what is f of 6? What is f of 7? What is f of 8, 9, and so on. Now let's see what else they ask on that question. Oh, me. Graph f divided by g. Again, it's not gonna give you much because f divided by g f divided by g is going to be the square root of x minus 5 over 2x squared minus 4. And again, there's not much you can do with it except just put a division symbol between it, graph it, and let's graph that one. We'll graph that one in yellow or something. Well, hold on, I got to find my calculator. So we'll graph that, and that'll be magenta. And we'll do the same thing, except just put a division symbol. So the square root, if I could find the square root symbol, x minus 5 divided by parentheses 2x squared minus 4. And graph that one. And we're going to have to do something else. So let's do zoom back. I don't think you're going to be able to zoom both. I don't think you're going to be able to do both of them. All right, what I might do is zoom in. I'm going to try to get both of them. That way you can see that there's really not anything. There's sometimes they give you stuff and you just can't do anything with it. Well, zoom box. Get a little bit of that blue one in there. Okay, you're not going to be able to get that you're not going to be able to get them both in there. So, but you can see if you go to the second one, trace, and you could jump down to that one. It starts at 5. And then it just keeps to see what it's doing. It's not doing very much. It's not moving very much as far as the Y scale because you're dividing by a big number. So it's going to hang around 0. Okay, let's see what else they ask about that. Sorry, I'm all over the place. There we go. What is the domain of f divided by g? Well, we said it was 5 to infinity. And then compute f composed of g, and then plug in a -3. And then, now this is a good test question right here. Okay, so you might want to write that one down. Let's do compute, and I'll write it down while y'all are writing it down. F of x is equal to the square root of x minus 5, and g of x is equal to 2x squared minus 4. And they want you to compute f composed of g with a -3 and g composed of f of a +9. Now this is a good test question. This is the kind of stuff I'll ask on a test. So I'm going to rewrite, and yes, I'm going to keep doing this highlighting thing until y'all catch it, because some of y'all suck at composition of functions. Because that's just, for every 10 students that's taken algebra, about 6 out of 10 suck at composition of functions. So that's why I do the highlighting, so you won't screw it up. So I'm going to rewrite f with a big set of parentheses. And I'm going to plug in (2x squared minus 4). And I'm going to rewrite 2 big set of parentheses minus 4 and plug in the square root of x minus 5. Now simplify those and then plug in a -3 and simplify this, plug in a 9. So I'm going to give y'all a minute to work on that. Now I did tell y'all I was teaching 130 next semester, right?
Did. Yep.
Okay, did I tell y'all which section it was?
Like the 5-digit number?
Yeah, did I give y'all that?
Yeah, you did.
Okay. If anybody wants it, hold on, I think I got it. I'll show it to y'all. I just remembered I've got a Word document in here that I fixed. Just let me see if I can find it right quick. Let's see, document spring. So those of you that didn't, there it is. There is the 130 right there. 429.19. So make sure you write that one down. 429.19. $429.19. Okay, so let's see what we got here. I'm going to simplify this. Well, there's really nothing you can simplify because there's nothing in here you can actually, you could do the -4 and the -5, and that's going to give you the square root of 2x squared minus 9. And I'm going to plug in 2 -3 squared minus 9. And that's going to give me square root of 2. What's -3 squared? That's 9. And what's 18 minus 9?
9.
And 9 squared, 9 cubed, square root of 9? 3. Here, this cancels out with that. So that leaves 2 times x minus 5 minus 4, 2x minus 10 minus 4, 2x minus 14, evaluated at 3, or 9, sorry. So that'd be 2 times 9 minus 14 is 18 minus 14, which is 4. I'm going to leave that up for a few seconds. And that should be a 3 and a 4. Let's see what they got. Three and 4. And of course they did everything on calculator, but there's some things I don't particularly care that you do on a calculator. You should not punch. No, I'm not even gonna worry about it. Now this one I didn't know you could do that. I'll have to figure out how to do that. Somebody know how to do that? I've never done that before. Yeah, you'd have to blow that up. Let's see. Yeah, the reason ours was flat is because I told you couldn't graph them on the same. It's going to be hard to graph. Now, if I went to y is equal and took out this one, and then graph, and then zoom standard, it'd probably give me a better, okay? How about zoom first quadrant? Okay, we're not getting, y is equal to, well, I typed it in. I don't know why I'm not getting the same picture unless the window, let's see, x minus 5, unless they're blowing up the window very, let me look and see what they're, wow, they're getting, I'm trying to figure out what that 0.016 is because this says 5. Why is that 0.016? Oh well. And that's it. So that's basically the end of 4.2. Now let's see what 4.3 holds in store for us. 4.3, where is you? 4.3. One-to-one inverse functions. Okay, how do you find an inverse function? All right, well, let me go to my handy dandy. I'm just going to talk to you about what is an inverse function. Well, an inverse function is usually a function. An inverse function is a function that switches x and y coordinates. Okay, basically, if you have a function that gives you 1, 2 and 4, 6 and 6, 8. Let's say this is f of x. Then the inverse function, which is f to the negative 1 of x, would give you 8, 6, 6, 4, and 2, 1. Okay, basically they flip. They put that one there and this one here. Okay, they put this one here and this one here. And they put this one here and this one here. So you have technically a mirror image across some axes. Now sometimes it's across the origin, sometimes it's across the oblique asymptote, sometimes it's reflected around the y-axis. Okay, but it is usually a mirror image. Now there's two ways to see a inverse function. Two ways. Two ways to see an inverse function. One is by graphing it. And an inverse function, I'll show it to you in just a minute. Be better if I did it on a calculator. Well, here's an example of an inverse function. F of x is equal to x squared, and y is equal, or x is equal to the square root of y would look like this. And it does not exist under here. So I just draw a dotted because it don't exist. You can't take the square root of a negative number. All right, so anyway, you see that there's a little bit of symmetry here, and technically there's a line that goes through here called the oblique asymptote, and it's a mirror image around that asymptote. All right, you'll see it in just a minute. And algebraically, you follow the same steps. Number one, make sure
You have a work email.
you have x and y. So if you have a f of x, change it to y. And that's usually what you do. Usually you're going to change f of x into y. That's usually what you're going to do. 2, switch X and Y's. 3, solve for Y. Now, I know that sounds kind of redundant, but we're gonna do it here in just a minute, and I'm gonna show you the graph, and then you'll see what I'm talking about. Okay, so 1, make sure you can use your graphing calculator, because you're going to see by graphing, and like I said, 4.1 is a lot of graphing with the calculator. And then 2, I'm going to ask you to do it algebraically. So with that being said, let's do 1. And we're going to do it algebraically, and then we're going to graph it. And this is a good test question. F of x is equal to x cubed. Okay, the first thing you're going to do is you're going to get rid of that f of x, and you're going to say y is equal to x cubed. Now you're going to switch the x and y's. So it's going to be x is equal to y cubed. And now you're going to solve for y. Well, if I want to get y cubed undone, I'm going to take the cube root. So y inverse is equal to the cube root of x. So now we're going to graph the 2.
That was a lot easier than I thought it was going to be.
Ah, yeah, that's the way you do it. So now we're going to graph it. Now, Miss Hollister, you know you're not supposed to talk. Your classmates are going to get mad at you.
I was just cursing out of my head.
What? What'd you say?
Nah, it's too vulgar to say. I can't tell you.
Oh, okay. Well, you're not supposed to talk, Miss Hollister. You're supposed to be there, and you're supposed to be quiet, and you're not supposed to communicate. Do you understand, Miss Hollister?
Yeah, I got you.
All right, so here we go. Remember, your goal is to be in a closet office for the rest of your life. So you don't communicate. You just sit there. All right, so here we go. I'm going to graph f of x is equal to x cubed. So that's going to be x cubed. And we're going to do this in black. We'll do that one in black because it's kind of like the basic model. So we're going to do that in black. And now we're going to do the other one in magenta. And we're going to clear. And we're going to say y inverse is equal to the cube root. So that's going to be, I'm going to do to the 1/3 power. So that's going to be parentheses, x, close parentheses, raise it to the 1/3 power. Okay, so we've got x to the 3rd and then the cube root of x. And watch what happens. Now, I'm going to throw one more thing in here. I think, and that's x and it's dotted, I'm going to type in x is equal to y, or y is equal to x. Basically, the oblique asymptote. And I can't, there we go. So watch this. Now I'm going to blow this little area up right here. Zoom box. And there you see the symmetry. It's usually either around the origin or the x-axis or the y-axis or the oblique asymptote. Now watch this. Hit trace and see if you can find a good even number on the black. Let's see if we can find a good. No. I was going to say, hopefully we could find something. All right. Well, no. I don't want. No. All right. Let's just do this. Let's do. I was hoping to get something. Okay. There was one. Okay. 1.275, 1.275, comma, 2.07. So on the black, and I'm going to zoom out just a little bit. There we go. Okay. Now trace. And I'm going to get back close to that 1.275. Okay, that's close enough. Let's go with, well, we got 1.275 written down. Well, no, let's do 1.294, 1.294, and 2.168, 2.16. 1.294, comma, 2.16. Now I'm going to jump down to the pink one. And I want to find I want to find 2.16. So I'm going to go to 2.16. It's close enough. And look, they're switched. Okay, it's not exactly 2.14. It's not exactly 2.16, but you can see that what used to be 1.294 is now 2.14, and what used to be 2.14 is now 1.28, 1.29. So you see that the function actually is a kind of a pet cemetery thing going on. In other words, it's kind of the same function. It's just the bad part or the good part, whichever one you want to look. You know, Pet Cemetery. You ever seen that movie? And then, okay, Pet Cemetery. You take your dead pet, you bury it in the cemetery, and it comes back to life, but it's evil.
Yeah.
Y'all don't watch any movies unless it's animated, do you? It's the only thing y'all watch now is animated. Anyway, Stephen King, Stephen King, Pet Cemetery. Do not watch Pet Cemetery 2. That was a stupid movie because you do not mix horror with with humor. I don't know why they try to do that, but you don't mix horror with.
But you can, though, Mr. Hubert, you can.
No, you can't.
I'm not going to say that was a good example of it, but you can.
Tell me a good example of mixing humor with horror.
Okay. I've heard of, okay, you know what? I think you're right. But it was more like, it was like a scary movie, but it was funny. But it was parody. It was a parody.
They tried to do it. They tried to do it with Scream. And that didn't. I never did. I barely got through one of those movies. I'm a diehard horror. I like horror.
Oh, I love it.
I don't like putting comedy with horror. Okay.
Hubert likes to watch CNN.
I'm sorry, what?
I said, yeah, you like to watch CNN, right?
Oh no, I don't. No, that's called fake news. That's what.
Yes, of course.
It's called Kool-Aid is what that's called. Anyway, that's basically what an inverse is. You're talking about it's the same setup except it's different. And I like to use the Pet Cemetery thing. It's the same body, the same vessel, except it's not good, it's evil. It's the opposite. It's the opposite, inverse. Okay? So yeah, CNN, you can use that. It looks like news, but it's Kool-Aid. It's fake news, propaganda. All right. So with that being said, let's do a nerd. Let's do the function that I gave you a while ago. Let's do, well, I don't want to do x squared, but let me show you x squared and how it looks. F of x is equal to x squared. Y is equal to x squared. X is equal to y squared. Y inverse is equal to the square root of x. So here, your function is x squared, and your inverse is square root of x. Now, you're only going to get half the representation here because you can't take the square root of a negative number. So that, with that being said, let's go to the handy dandy calculator. And y is equal to x squared and this is going to be equal to 1/2. And I'm going to blow that little section up right there. I ain't kidding. Y'all just learning so much in here. Y'all ought to be y'all getting your money's worth. All right, so here we go. Enter. Turn, this thing moves fast. Don't move that Wabbit EMU, it don't move as fast. There we go. Oh. I'm about ready to quit. Damn Russians. So if I hit trace, let's pick a point. 1 should be 2. There we go. Or 1 should be 1. There you go. Well, I don't want to do 1, 2. I want to do 2 and 4. So let's go to 2 and 4. Okay, does everybody agree that the square root or 2 squared is equal to 4? I think everybody can agree with that. Okay, so 2 is equal to 4. So let's turn it around and let's go to 4. X is equal to 4, and we should get y is equal to 2. Ding! Let's zoom out. Dadgum. Don't even zoom out. Okay, there it is. Trace. So there, let's go with, let's see, what I say, 2 and 4. Okay, there's 2 and 4 right there. 2 and 4. And then if I go to the other one, and I go to 4 and 2, or I go to 4, it should say 2 on the Y. Well, 3.92, you see it's getting toward 2. As soon as I get to 4, and you can do it on the Windows, second table, and just go find 2 and 4. 2 and 4 turns around, and I go to 4 on the other, go to 4 and it'll say 2. So if I go to Y, go to 4 down here. Okay, it's doing it. It's not doing it the way, it's not doing it. It's doing it in X and Y, so you have to turn it around. But you get my point. So that's how you do inverses. So let's see. They're probably going to talk about even and odd, but let's see what else they talk about. Make sure you write down the horizontal line test. Horizontal line test. A function is 1-to-1 if no horizontal line can intersect the graph more than 1 point. And I'm going to give you an example on the next slide. This is not a 1-to-1. Okay? Because if you do a horizontal line test, you hit it at 2 points. If you do a horizontal line test here, you only hit it at 1 point. This is 1-to-1. This is not. 1-to-1 means for every X, you got a Y. Here, for every X, you have 2 Ys. Or every Y, you have 2 X's. So you can't have a 1-to-1 and have 2 points with 1 point. That is a test question. The horizontal line test, that is a test question. So right now in 4.3, you're talking about graphing an inverse function, algebraically finding an inverse function, and the horizontal line test. This is going to be a real easy test for some of y'all, especially if you know how to use a calculator. Not depend on it. All right, here's one right here. Here's the test question right here. Determine if f of x equal to x cubed minus 1 has an inverse function. So let's do that. F of x is equal to x cubed minus 1. So y is equal to x cubed minus 1. X is equal to y cubed minus 1. X plus 1 is equal to y cubed. Take cube root, take cube root. So y inverse is equal to the cube root of x plus 1. So it does have an inverse. So let's graph this one. X cubed minus 1. Sometimes these calculators can be very aggravating. X cubed minus 1. And then your inverse is going to be the cube root. So I'm just going to put parentheses, x plus 1 x plus 1 to the 1/3 power. And graph. I think we already did that one. I'm not sure. But anyway, there it is. So we just solved that one and we graphed that one. And both of them are 1-to-1 because you can draw a vertical line test through it or horizontal line test. Here they're telling you how to, there's the, how to find an inverse function. I already showed you how to do that. There's one. That's pretty much it. So you go to your homework and you pull up your homework assignment. Let's see, back up. Assignment. And go down to 4.3. And determine whether this function is 1-to-1. Well, I'm going to graph it first. So I'm going to graph y is equal to clear, clear, and clear. Okay, square root, x minus 5 raised to the 3rd power. Now, by the family of graphs, I know that this function looks like this. I know that the function looks like that. But what do I also know that's given in the question? Look at the question. What is that -5? What is that? Starts with a H. O. R.
Horizontal line.
Horizontal shift.
Okay.
And that's always the opposite. So that means I'm going to move to the right 5 places. And that means my function, my new x and y axis is right here. So that means that the final outcome is going to look like this. And I'm going to draw my horizontal line test through it. And it only crosses one time, so it is a 1-to-1 function. That's the kind of test question I would give you, because that is a 1-to-1 function, horizontal line test. I just gave you that question. Let's see if I can find you a question. Okay, that's a vertical, that's a horizontal line test. Yes, that's. Okay, this one, you graph it. And I have, let's say x to the fourth. What is x to the fourth? Family of graphs. What is x to the fourth? That means I want somebody to say something. What's your family of graphs say to the fourth? If your exponent is to the fourth power, the sixth power, or eighth power, what does it do to the parabola? Squares it off, Hubert. Yep, that's right, class. So that's what x to the fourth looks like. Does it hit twice? Yep, so it is not a one-to-one function. So if you know your parent graphs, you can do these in like no time. Okay, complete parts, write the inverse of 4x minus 4. Do the values for f of 1. You just flip them. That's not a big deal. I don't like that for a test question. I'm trying to find one that you actually find the inverse. There we go. So this one is a test question. G of x, 9x plus 5. G of x equals 9x plus 5. Y is equal to 9x plus 5. X is equal to 9y plus 5. Minus 5, minus 5. X minus 5 is equal to 9y divided by 9. So y inverse is equal to x minus 5 divided by 9. That's the test question. So we go to the handy dandy question and type in fraction x minus 5 and 9. And same thing there. So that's your hardest questions, is algebraically finding the inverse. 13. What does the inverse function of a cube root look like? Well, I can tell you it's not C, and it's not D. It's not Charlie, and it's not Delta. And this one looks like somebody drunk drew it. So which one is it? It's alpha. You don't even have to do anything on that question. You just have to use a little bit of what? Starts with a C. O.
Common sense.
Common sense or deduction. You know it's not this one because there ain't no parabola up here. Family of graphs. You're looking for the squiggle. Well, that one's a squiggle, but that one's a parabola. So that's not it. These are two parabolas. Oh, well, these are two, but that's not it. That's not going the right direction. This one, is it symmetrical? This one is. I didn't check it. I'm sorry. Is the function, is it? Yes, it's 1-to-1 because it's a cubic function. So it is 1-to-1. Does it have an inverse? Well, let's do it in our head. Let's see, y is equal to 3x, so x is equal to x minus 9, x minus 9 divided by 3, cube root of x minus 9 divided by 3. Yes. The function that converts 1 pound of a country, a function that converts pounds of country A to dollars of country B is blah, 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 where X is the number of pounds of country A and f of X is the number of dollars of country B. Find the inverse for F. Well, f of X is equal to, so that would be Y is equal to 1.97 blah, blah, blah X. So switch it. X is equal to 1.9. So that would be X. Well, hold on a second. F of X, that would be X is equal to 1.97Y. So it'd be X divided by 1.927. So that would be X divided by 1.9727. So if I convert pounds to dollars, this one is going to convert dollars to what? Country B to country A. Thank you, class. Oh, suck. Okay, and then you're just gonna plug in $8,000. I'm not really. I think y'all should be able to plug in $8,000 into that equation. Okay, so I think y'all got the gist of it. Okay. So, what does that mean? Well, let's look. I know it's time for y'all to go. Don't spaz on me. Just bear with me a minute. That's the test right there on 4. I'm going to go ahead and assign it for right now, but it's just going to be, let's see, I haven't assigned the homework on 4 yet, so I'm just going to open this one up. Assign, and we'll set it next week. Some of y'all can go ahead and play with it if you want to. Let me open it up and settings for class. I'm just going to open it up. No date right now. And some of y'all that want to play around with it, you're welcome to go ahead if you feel spry. But I'll probably, more than likely, Tuesday will be our last day of questions and review. So y'all should go ahead and knock that test out. I want to try to get us through logs. You're going to need logs in 130. I'm not worried about chapter 6, but I want to get us through logs before we finish, maybe next week. Okay? Anybody got questions? Let me look at the attendance since it didn't save last time. I'm sorry, I got to go through it again.